We are back again for the aeronautics session this year, and the focus is on the next generation aircraft system. It is the next generation singular we're focusing on, and there are a lot of opportunities, but also a lot of barriers, and we would like to discuss this with our panelists, but also with you. There will be the opportunity for a Q&A session. And first of all, I would like to thank JSC to have this stage, to have this opportunity, to have this great panel here. And I would like to thank SD Engineering for being, again, the supporter and the sponsor of this session. And a big hand of applause for JSC, for this panelists, and also for SD Engineering. So, my name is Mark Vetter. I'm the CEO of the Composite Technology Center of Airbus and also one of the presidents of Composite United. This is a composite network, composite association in Europe. I would like to take the chance to introduce our panelists. First of all, there is Ashley Tracy. She's also president of a big association, the SMPI in North America, and she is working for the Boeing company as a material and process engineer. Big hand of applause for Ashley. Then there is William Ruppertsberger. He is the head of Plastics and Competence Center and at Phil in Austria. And he is presenting the machinery producers, which are really important because it is much more focused on the industrial systems than ever before for development of a next generation aircraft system. So a big hand of applause for Willem. Then we have the representative of SD Engineering as our sponsor. There is Mitchell Smith. He is the Vice President for Operations and Technology, and he is back again on this stage because last year we had also a great speech and a panel here. So big hand of applause for Mitch. So then we're coming to an SD Engineering Airbus company, to the ELBE FLUGZEUGWERKE, which is an MRO, but also a converting company for passenger aircraft to transport and cargo aircraft. And I proudly present here Alex Knorr. He is the CTO of ELBE FLUGZEUGWERKE. It's great to have you here. And then we have also the material producers represent from HEXCEL. This is Bertrand Gemont, and Bertrand is the Vice President Technical Support for Europe and the Asia Pacific and EMEA room. So great to have you here. Also a big hand of applause for Bertrand. So now I would like to hand over shortly to Mitch as our sponsor. Mitch, the stage is yours.
Thank you. Making sure it's on. SD Engineering, for us, we're so happy to be able to sponsor this session. For myself and for our business units, it's one of the key things for us is to take the products that we make and design and how we get them out into the field and put on platforms. ST is in a great position that we not only do the OE product side, but we also handle the life cycle of the aircraft all the way through MRO, P2Fs, a variety of structures. So these things and these decisions that we're going to make and how the industry is going to go forward, they're going to be key to how we organize our business in the future for the next generation aircraft. If it's an all-composite aircraft, it'll be a very different animal than we deal with today. So it's important for us all, as our whole industry, to make sure that when we take these decisions and move forward, that we can actually be successful, because we'll have to own it, Alex and myself, at the end of the life, and how you relife it, and also how you're going to build it. So thank you for JEC for letting us do this. Hopefully we can continue on. And Mark, thank you so much for being a chair. Thank you.
Thanks. So I would like to come to our panel discussion now. So, first of all, we would like to understand why composite structures still struggle to reach out the cost, but also the production rate targets. needed for next generation aircraft. So mostly targeting with 80 to 100 aircraft per month per OEM. So it is a dramatic number, but also the demand is really, really high for the next decades. And I would like to start from the material representative point of view. From the material standpoint, what remains the biggest cost driver presenting composites from becoming a default choice for the future single-aisle aircraft?
Yeah,
Simon.
thanks, Mark. Maybe first answering directly the question, I would like to state we've got large programs like the 350 or the 787, which I think already has been really instrumental in scaling up the composite in general. So all the materials, the processes, both goes together. So thanks to these programs, we know as material suppliers in general, not just HEXCEL producing large quantities of material, we had to scale up the carbon fiber manufacturings. And this is driving the cost down, high Kato fiber, high performance, the resin mixing, the filming, everything has to be scaled up. And this is already a lot has been done. But they are wide bodies. So you're right, Mark. I think the challenge of the next single aisle is the rate, is to reduce the cycle. When you have to produce 3 aircraft a day, that's a major step. So I would see three areas. One, which is really material driven to further drive the cost down, is reducing the cure cycle. I think this is a lesson learned from the 350 or other materials. I mean, it still takes quite a lot of time to cure the resin, whatever it's pre-preg or infusions. So I think there is clearly potential here. Also investing new processes, RT not out stamping or high pressure RTM. That there's many ways to reduce the cycle and reduce the cost ultimately. Another one, which I think the materials which are in play now are really, really robust. And I think when I look on the inspection of the parts, NDT, each component today and each square centimeter of the part has to be scanned and checked. So I really would love to think that that's something in the future program which can be reduced or eliminated. Let's dream, and so that I think it's a cost burden today in a supply chain, and it's a cycle bottleneck as well. And finally, to conclude, I think the thinking composites rather than black metal. I mean, it was the case on 350 and 787, but I believe more can be done to really integrate from the beginning the material and the processes, so you can really reduce the cost from one end to the other. The material is one thing, but it plays the roles all along the processes, but it's not only the materials. It's all together. We have to reduce the cycle, so to meet the rates and further to drive the cost down.
So I have one more question to you. So when we have a look, especially to Europe, we are talking about resilience and building whole value chains also for the materials there. Is there a point where you're thinking it's necessary also to think about to have the precursors, not only the fibers and the fabric production in Europe?
Yeah, we have. I mean, Ring for HEXCEL we have, but yes, I think it's something for sovereignty, for robustness of the supply chains. I know it's a concern from OEM. On such large quantity, you need several points of supply. You need interchangeability. Yeah, that's critical. And you start from the pan. If you don't have the pan, you don't have the carbon fiber, definitely.
So now I would like to ask ELBE FLUGZEUGWERKE. You are at the end also manufacturing parts for aircraft OEM as a first tier, also second tier supplier. You make aircraft conversions, especially for Airbus. Which protection rate or manufacturability constraints still make metal structures easier to deploy, to handle, to scale up compared to composites?
Yeah, the metal structure actually seems to be the better choice. If you go to a high rate manufacturing, as established supply chain, the reserve factor is given.
So, but the gap is becoming closer. So composites developing further. We have new calculation methods in place. We have new manufacturing technologies, and the reserve factor is coming down from the raw material over the technology and all that. So that from the first point of look at, you can say, okay, metal seems to be the better choice. But in any case, you have an overlapping by the existing technologies. You can manufacture it in metal, you can manufacture it in injection molding or RTM or whatever. On the end of the day, it's the question how you can source the material, how many changes you expect in the future on cabin modifications or structural modifications. This is the main key driver. If you have changes, you have to respect changes in the tools, in the raw materials, in the semi-finished materials. And on the end of the day, the tool changes more or less affect the business case at all. And if you have metal technologies without any issues for manufacturing special tools or something like this, you can be more flexible by bending, milling, drilling, combining technologies to gain the same result instead of a composite part where a mold or special tool is needed. So, and if you expect a certain period of time without changes, definitely the first choice is composite from the cost, from the lightweight perspective. By the metal parts, you have even more issues with the upcoming regulations for corrosion prevention, chrome-free anodizing, and all these things. And all these process steps has to taken into account if you select the technology, and as well also the capability to serve spare parts later on in the market. From our point of view, it's not serving the OEM with the parts and go away and that's it. No, we see that the part is coming back in 20 years, 15 years old with the maintenance issues, and sometimes this knowledge is also painful. Why you have to reflect this in the design with the knowledge, okay, this could happen during the operational phase. And coming back with all the pain points after the operator has had the performance over 20 years with the part.
Imagine there is a full composite aircraft. So you are making also conversions for single aisle, for A320 family. What are the challenges in this case you see to make a conversion to a cargo aircraft with a full composite aircraft? I know these pictures where you make the first metal cut. It's not the first metal cut for a part, it's the first metal cut in the fuselage of an aircraft. So it's horrible for an aircraft manufacturer to see this, but I have these pictures, and what are the challenges there? Do you have concepts for this, or?
Maybe. Yeah. The expectation that the next aircraft, the next composite aircraft, is coming back to the possibility to convert it into a fighter. Maybe it's a long way to go. But back to the technical challenge of your question.
I think, though, the question mark for you and Ashley, what is the basic architecture going to be of that new single aisle? If it's different than today's, with an architectural perspective, the conversion will be dramatically different. Is it section modular? Are we pulling the section out? We're doing panel work? What that architecture defines the P2F process. Yeah. So it's easy to cut a hole in aluminum and put a doubler on it. Sure, it's a lot harder to do that on a min-gauge composite structure. So I think you'll have to help us define what we're going to need to develop.
For sure, I guess we have to do it together when this is an important point, and we have to take this into account when we are developing and engineering such an aircraft. So, yeah, what's your opinion, Ashley?
I totally agree. It's really a journey together, working across, from material manufacturing all the way through to application, fabrication, and then what do we do at end of life or change of life from maybe a commercial jet to a freighter.
And the pure technology point of view, if the design is more or less with split lines in the original design of a composite aircraft, or is a full integral design, you have to cut. If you have a metal part, yeah, you cut it, you have chips, you can remove this easily. Cutting a composite part, as you all know, is the other kind of thing. You have dust sticking on all the surfaces and all the things. The question for me is not, is the technology ready? So it's the same like mid-rise. How does it look the next generation? Is there a possibility for disassembling, or is there a need for drilling, milling, or whatever, in the case the fuselage is more or less one piece?
So this is an absolute good point, and I will come to you as an MRO. I know you are also MRO, but ST Engineering is one of the biggest MROs we have. What we have to take into account as an aircraft manufacturer, but in total, when we think about the concepts, this is maybe a similar question to this question before. Should we have other manuals, other methods to make repair, maintenance, overhaul? Is the mission really important of the aircraft, because it's much more different than for 787 or A350, also availability of professionals. So what are the key points you are taking into account?
So from an airframe MRO perspective, right, as we live at the back end of the margin stream, right, we get the least amount of margin at the end of the day, typically on those overhauls. So cost sensitive. I think the biggest things is going to be if we're going to go to all composite aircraft, and there's going to be a massive change in how we're going to disassemble, reassemble, do inspections, do repairs, fasteners, cost of fasteners, right? For instance, those things are very expensive as well when you switch away to all tie. That's going to put a lot of pressure on the MRO side of it, right? So I think the important piece is that you're going to say, okay, I'm going to field this thing. Eventually, you're going to have to do your A, B, and C checks and those things on the airframe and on the engine components. But when you then go to actual P2F of it, or conversion or end of life it, I think all those decisions have to be made around it. When we typically deal with your customer, right? We're doing MRO for the airlines. Well, it's a different animal than dealing with the OE guys. So I would just say that please involve us and say, okay, this is our strategy for how we're going to do this MRO activity, so that then we can prepare ourselves. My guess is going to require capital investment in different capital than we have today. And that'll be the biggest challenge, is how much capital can you deploy? I mean, we have many, many facilities all over almost all over the whole world, right? So if you're going to start changing how things go, then we got to figure out how to capitalize to be able to actually handle it.
When you look to the people, because we talked about before, it's also all about people. It's not only technology. It's not only business case.
Mobilitätsindustrien.
We see the challenges there, and professionals, training, especially for inspection, NDT. We have today bottlenecks. What does this mean for the future?
So Wilhelm is going to invent the automated everything machine that does it for us.
What machine?
The automated everything. We call it the AE machine instead of AI.
This was a great handover to Wilhelm. So yeah, maybe this is one point you will mention for the opportunities at the end, for the end-to-end automation, digitization for the industrial system, but also what are not only the opportunities, what are the challenges you see as a technology and machinery provider, which is really crucial, as I mentioned, for the industrial system, and also the importance for the industrial system for such an aircraft.
Yeah, we speak about high rate, and one statement at the beginning, we like high rate. So Phil works, I would say, more than 20 years in the field of aerospace manufacturing systems, but we have another business in automotive, and we have a really nice reference for composite automation. We build all the machines for BMW, for the Project i3 and i8, and they produce a year 1.5 million parts, preform parts, dry fiber for the R10 process. So we know a little bit how to handle a high automated production, how to take care of all the data, and how to optimize these processes. So this is what Phil can bring in the game for this new aircraft with these high numbers of pieces a month.
So the last years, often when we speak about high rate production, then we are also focusing on thermoplastic composites, not only for single part production, having into account the whole integration, especially functional integration, taking about the opportunities of joining technologies. What would you say, what importance and what we have also to do for introducing more thermoplastic composites for such a next aircraft?
So I think there's, a number of challenges, and we've talked about some of these things before. So from the materials side of the world, we do have more thermoplastics options available today, but that certainly doesn't compare to what we have in the supply base for thermosets. And maybe part of a result there is our cost is a little bit higher. The volumes aren't quite where they are for thermosets. We also have challenges that we need to solve on the processing side. So thinking about large scale parts, some processes we can do that. Other processes, we're limited on the equipment that we have today. And then we also have some M&P that we need to solve as well. So when we look at things like bonding, joining, repair, there's still a lot of work that we need to do. Even if we're looking, we talk a lot about welding. Even if we're looking at welding, we don't have all of the tools that we can take out into the fleet today to be able to do welded repairs or other joining repairs. And we still have work to do on the front for bonding technologies. We've done a lot and really developed robust bonding systems for thermosets, but we're still in process of doing that for our thermoplastic materials.
That's wrong. When you look to thermoplastic composites, so this is also an important topic for you, but I guess most of the materials you are selling today, it's not thermoplastic. No, so thermoset. Where see the opportunities, but also issues in scale up, for example, and maybe let's also come back to the topic of resilience, how we can manage the risks from the raw material to the fabrics we are using.
Well, I can only agree with Ashley with all the points you made. It's not the same maturity. I believe there's a room for this. There's some benefit well known of thermoplastic over thermosets. I see welding really as it's the beauty of the thermoplastics, but it's the challenge as well. How you, and for the Airworthiness Authority, how you certify welding. I think the point is not to weld and put rivets in it. So that's things where we still need to work on. And yes, I believe from the chemistry standpoint, on the polymer side, this is not the same scale as thermosets resin are today. So a little bit of chicken and egg. I think you need more applications, so the volumes will grow, and the same will happen to thermoplastic as what happened with thermosets.
From the FLUGZEUGWERKE perspective, so also you are using a lot of thermoset technology. Are you also preparing for thermoplast applications, reinforced, not reinforced, and maybe also with a look on MRO, which we have to take into account there. So we are often easily speaking, we can weld it, but when we honestly taking high performance thermoplastics, it's much more difficult to do this.
Yeah, definitely. So, first of all, we have a lot of thermoplastic materials in research or maybe also in the qualification line. So maybe replacing complex milled parts or something like this with injection molding. So this technology is more or less available and also available from the tooling point of view for small quantities, becomes more interest for us, so that the overlay from the tooling is not that expensive. So this is a main point. On for the large scale manufacturing, it's the question of what is large scale. If you have a high customization rate, tooling, manufacturing rates, on the end of the day, thousands parts a day or 1,000 geometries a day. That's a main topic. And normally, if you look at an aircraft, all the parts look like the same. But Airbus had the challenge at the A350 with the clips and all the design around. So I can mirror this back. You had this challenge 15 years ago with a scale up. It looks like a large quantity, but on the end of the day, on a part number level, it's a less quantity. And obviously on the raw material side, the thermoplastic is slightly more cost intense. And you have to cover this with a smart process and a smart inline inspection. So that's definitely a key point. And to the part of the question from the repairability point of view, on the end of the day, you need a part taking into account that the cost of ownership perspective is key. The operator wants to have a part which is reliable, durable, maintainability, and repairability. So with not special processes, with not a climate chamber or whatever, it should be easy to handle in the repair and in the inspection, all on this globe, from Auckland to Anchorage, in each climate zone, in each hangar. If you're talking about A320, we're not talking about fancy environment conditions in a hub environment. No, we're talking about small hangars, small airfields, not airports in any case. And all these technologies have to feed these benefits of these stakeholders in this chain to gain a success for all. Why, if you create pain points on the operational science, you will never gain customer satisfaction at all.
Mitch, where you see, we talk a lot of opportunities or challenges, but where you see from an MRO perspective, see opportunities to use composites. So we got some insights from, of course, some airliners, and for A350, I guess also for 787, there are a lot of benefits to use composites. Where you see the opportunities?
So I think from our customer's perspective, or your customers as well, the largest advantage or the biggest benefit is the non-corrosion aspects of it. So when you look at what you're doing C-checks and H, like when you go through the fuselage, you go through the wings, just the fact that you really don't suffer from corrosion problems on A350 or 787, which every other one you do, right? It's just the nature of the beast. So I think from an MRO provider, there's some advantages to that now, because now you don't have to do as much work to mitigate that corrosion, stripping it off. I mean, the process is miserable, right? So I think from that side of it, there's advantages for it. Also, there's less work, so you get paid less, right? So there is a reduction in revenue. So the hope is that we do less work, make more money, and then we'd be okay with it. But there are benefits. They're typically for the end user. For the MRO side of it, it's really just the quantity of work that gets processed through. Perhaps you can do a lot less, right? So it's give or take, right? Because it is a business. So you're trying to operate it as a business. Clearly the benefits for the end user are obvious. From the MRO side of it, it's, okay, how do we adjust the business to accept the fact that we're going to not have these sort of work packages? Plus, there'll be a period of time where it's a mix, right? You're still going to have all the old airplanes still going to be coming through end of life, and new airplanes are going to be falling into it. So you're going to have this dual type process, which maybe some facilities can only handle one type of aircraft versus the other. I don't know. It'll be an interesting mix. I'll put it that way.
Thanks. So Alex mentioned a really important topic, I guess, customization. So this is a competitive advantage in this case. But maybe, William, you're working also for the automotive industry. And what you see, what we can learn maybe from an industry like the automotive industry in terms of industrial customization, not fulfilling maybe each demand, making it as an industrial modelization concept, whatever, where you see benefits to do this, and what we can learn from other industries, maybe especially the automotive industry.
I think we have really to take care of what we can learn from the automotive industry. There are some features, especially in the field of automation, high available machines and systems. all the data management. I think there are things where we can learn from the automotive industry. Also, we can learn from other industries. For example, from the ski industry. Ski industry, a ski, you know, is really a composite. A ski is a high-rate product. A ski factory produces 300,000 per ski a year. So they have really high requirements on quality, on automation, and less human work on the parts. On the other hand, high requirements on the optic of a ski, because this is an end user part. So we can learn from different things, and we as a field, as a customized machine builder, we can use different, technologies and requirements from different fields to bring it to the aerospace industry. And hopefully this makes interesting for this industry that we learn from different areas. And this is what we do the whole day, to bring these ideas to the customer in a very customized way. Because we don't have a super machine, as you said, on stock. We don't have it. We go to the customer, understand the requirements, and bring all the ideas together to get a solution for this high-rate production.
So let's switch to certification. So as material and process engineer, certification plays an important role. And when we talk about high rates, not only high rates, also, I guess, rate flexibility, ramp up, scaling up this in an industry, what we have to change in terms of certification for our business, for our market?
I don't know if it's so much of a question of what we have to change, but I think it's really more so a rigorous approach to certification. So when we're thinking about it, there's really kind of three areas or focus areas that we need to consider for certification. Number one for M&P is characterization of the process and really evaluation of the sensitivity of the process control. Number two is really figuring out and defining, what are these aspects that you're going to pull into your process control plan, as these are really, really key to implementation of robust technology. And then lastly, number three, especially when you're thinking about any sort of joining methods, whether it's welding, bonding, or any other type of joint, you have to think about the criticality of that joint, and you also have to think about the environment that joint is going to be used in. And when I talk about environment, I'm not just talking about, temperatures, pressures, fluid exposure. I'm also talking about mechanical loading, because all of that is really going to help you define your path to certification. And when it comes right down to it, it's really a joint effort between the regulators and the OEM, building on applications over time. We have a tried and true history of starting with smaller, less risky applications when we're introducing new technologies, new materials. And as we gain experience over time, we're able to scale up and increase to different, larger, more critical applications.
From a material developer and producer perspective, would you add something?
Yeah, we are, composites are engineered materials by essence. So you put the fiber where you need the fiber for the load. You are optimized. You optimized everything, your ply thickness, your functions of the resin. So that's the beauty of it. In the end, you tailor it exactly for your needs. The drawback or the weakness I was about to say is each material in the end, composite materials, is unique, and you have to qualify them, each one individually. And most of the time, even the same material will have to be qualified for Airbus, for Boeing. You restart everything from the beginning. So if I had a dream, it would be that if one day OEMs can agree on I'm talking on the bottom of the pyramid, so the basic specimen testings. I know the middle and the upper side of the pyramid is design specific. But for the bottom, if we could end up with a single qualification framework that would be great. Maybe it's a dream. Something maybe more realistic would be to consider maybe that the new material is an evolution and not a revolution. So not restarting from scratch. That will mean for material supplier maybe to explain, open a little bit the box on what have been changed versus the previous generation on the resin, on the fiber. So you just requalify what makes sense in terms of change of performances, and you do not retest everything, all temperature, all conditioning and everything. And final point is, again, referring to the 350 or the 787 is, I really do believe the material, the current primary structure material are very robust, very stable. They delivered in very accurate thickness, and I think both Boeing and Airbus can confirm. So I really hope there's room to reduce the number of batches and specimen you need to generate your statistical design values. We do 5 batches, plenty of specimens. I'm not mentioning the temperature or the different condition you need to test. This remains, but it's just the population. Because, latest generation shows the materials very stable. Composites are young materials. They're much more background on metal. But I think at what point, I believe it has to change. And the 350 and the 787, I think, did a lot for that. So I hope that the next one, really, we can simplify.
Well, and that's where I like your dream, and I do see, opportunity in certain areas, especially, when I think about repair, and I know that there's been efforts across the globe with the CACRC to look at standardizing, repair materials, repair processes. But then I also look at work that NIAR is doing with building an NCAMP database. And while we might not be able to just take that and go put a new material on an airplane, it's certainly a starting place to be able to work from a communal data set. So I also see that as maybe a stepping stone on the pathway to your dream, Bertrand.
Yep. Thanks. So, Alex, I know you have a mission in terms of certification. So, and I guess, also the look to Mitch says me. You want to say something?
Yeah, definitely. If you ask for what we have to change in certification, from the safety factor, nothing. We achieved with the system we have in place a level of safety which is outstanding. And that's the question is, the system is running well. But you mentioned we have an evolution of materials. And this brings me to the point, we have to be ready for evolution in certification as well. The material will evolve in the next generation. We go step by step over the next years. And we cannot expect, like we did maybe 20 years ago, we qualify a process, we certify a part, and we manufacture this for 20 years. No, we will see over the next years a development phase, materials growing, technologies growing, calculation methods coming to the next level. And this brings us in the possibility to achieve business benefits, lightweight design. On the end of the day, weight is benefit for the operator. And we have to be ready in the ways how we certify the material, the part, and we qualify the material to follow this evolution of the materials and not being pained by qualifying a new material 5 years later, fulfilling old requirements from the past with the knowledge 5 years ago. And this is the main challenge, to be flexible and ready for evolution in the paperwork to following the achievements from material and technology side.
But, so I would say that I always kind of step back and look at things from a business perspective. He lives in the high margin world. Everybody else runs downhill unless you're making spares. And that's the reality of the truth. It is the truth. I just look at every year annual reports, the highest profitable piece of our business in composites is you guys. It's a material suppliers. We shouldn't kid ourselves. It's the truth. It's great. I worked in it. I know it's fabulous. The bonuses are wonderful. However, at some point, talking about is commoditizing the material stream, and that's a painful process, right? The aluminum aircraft today, aluminum is a commoditized material, vast value in a commoditized supply chain. It's a difficult transition though, but probably it's what has to happen, right? That's for you to answer.
We will take this into account.
Okay.
So let's come to the production. So when you see end-to-end digitization, holistic automation, a lot of these technologies are developed. Sometimes in some pillars, some pilots in stage. But what is the next steps there? How we can bring it holistically into our industrial systems, because this is not the state of the art.
So I would also like to have a dream. So currently, what I understand from the aerospace industry, the parts are produced in different steps, in different stations, in different with different datas. At the end, we support to the customer a DT machine, and then they said, okay, the part is good or not good. I think this is not the way where we have to produce parts in the future. So we collect all the data, but we do nothing with this data. The dream is that we collect the data during the complete process chain, beginning in your side.
Yes.
In the pre-break line, that we know exactly the data from your process. We collect all this data, and then we can, using AI at the end, to find out where are the process parameters where we have to change. Maybe we have to change the temperature on the AFB head or something. We have to be more, we can have more data, and then we can optimize the process from the complete chain. We don't say at the end, okay, the part is good or is not good. This is not the way to produce in the future, and to produce rate. If you have to produce the rate, you have to take off each process step and to optimize it, and also to optimize the load of a machine. When I go to a factory, not to Airbus, but all the machines are not working. In my perspective, in automotive, every machine has to work all the day. There's no time for different things. It has to work, and these are the vision what I have, to use intelligent products, to use AI to optimize the complete chain, beginning on your side to the end. And this is my dream for the next years.
Hopefully we will realize it. But besides this stream, there are also some other points, area, space to have when we come to composite production for such a big number of aircraft. The other things are professionals, bringing the people into mind, not only for the OEM, the whole supply chain, the whole value chain should be addressed. What are the challenges for you, for Boeing, you see in matter of space and matter of professionals, both of these aspects, because a lot of the other aspects we already discussed.
And so are you asking a little bit about, like workforce development? And yeah, so I think there's a lot of opportunity there. We do have, quite a bit of work in composites, but we only have, at least I look in the States, we only have a couple of universities that offer degrees in composites. So a lot of, yes, you can take a couple of classes, you can get some of the fundamentals, but you do a lot of on-the-job learning. So it takes many years before you actually start adding value back to the company. So I do wonder about, working with universities, working with societies like SAMPE to help increase the general knowledge and capabilities of the workforce. I think that's definitely something that we need to work on, because right now the process is just taking a very long time.
I have a question. You speak about the young people, the students, they are very important. But what about the real experienced engineers who developed the former composite planes? Are they available or are they retired? So this is my thought about this. We will have a lot of young people, very motivated. But what about the seniors and the knowledge and the experienced guys?
This is a really important point also in terms of knowledge transfer, also in terms of changing professionals. The skills you mentioned for AI, for digitization, are a little bit different from the skills most of the people earned 20 years before, 10 years before, sometimes also today. So this is a point. But when we look to Central Europe, we have also demographic change, which is a really big challenge. Maybe it's not the same in the US, but for Central Europe, and when we look to Dresden, for example, where the FLUGZEUGWERKE, how will you address this topic? Because you have a lot of manual work today.
One of our values is definitely the high-trained staff. So to be flexible and can be active on each aircraft. So if you deal with old aircrafts, not each aircraft is in the same shape. It has a life, repairs, modifications has taken place. So you need a high-trained staff to deal with that. And this is experience on the end of the day. And we are faced off with the situation that we have the great advantages that the product life cycle of an aircraft is more or less 20, 30, 35, 40 years. But this means, as you mentioned, that you have your hand over the knowledge over this period of time, from a development phase over the operation and to the next aircraft. And if you have no new program ahead for a few years, and you're faced off with the situation that your employees haven't had in contact with a new development program, and the old ones going retired, the new ones have no experience. That's the challenge in the period of time. It's not the way old staff working together with young engineers or whatever it is. No, it's a question availability, being the same, being on the same task at the same time. If the one generation is going retired and the other one is not available, but it's still in the universities, it's not a question how you make knowledge management.
Thanks a lot. So we will open up the questions now for you. So when there are some questions in the audience, we have our nice colleagues there, which will hand over a mic. So please take the advantage to have questions for us, for our panelists here. So please raise the hands. Yes, there's one question.
You think for the future aircraft there will be a lot of autoclave type of composites, or will the cure cycle and the production time be too long for this kind of technology?
Well, I think I've briefly covered it at the beginning. I mean, we are fully conscious of that. So there are lots of developments going on for future generations to make to shorten the cure cycle in terms of chemistry, the formulation itself, make it more robust. I mean, an autoclave has the ramp-up phase, the cool-down phase. If your materials need a dwell, you can end up, it's true, with very long cure cycle. So that's an area we're working on. Out of autoclave, obviously, as well, and infusions, injections, large scales. I mean, RTM is developing a lot here. You can think about some kind of, like the metallic process, I mean, stamping, hot in, hot out, so you can, with automation, you can make your preforms or your stack of plies, whatever the UD or wovens, and then you just put them under the press, and you don't need to ramp up, you don't need to cool down. So yes, that's definitely a concern for the cycle, and things are coming, and we, as material supplier, we're working on it. Yes.
Okay, thank you.
Thanks. Are there further questions? takes a chance. Oh, there's a question over there on the left hand.
You see. Yeah, I had a question about what you were talking, the future of composites with the colleges. What about trying to expand into the school systems to get them at a younger age interested into this field?
Yeah, I think that's very important to start socializing opportunity earlier. I can speak for myself that when I was in high school, I didn't really understand anything about materials engineering. I did not know what it was. I loved physics, and a materials professor came from a local university and had a styrofoam cup and a solid plastic rod, and he handed them around the class. And of course, everyone assumes that the plastic rod is going to weigh less than, or way more than the styrofoam cup. And it did not. It was the same weight. And that's where I started learning about, density of materials, and I became very fascinated. So from there, I went on to get a degree in materials engineering. So then I look now to how can we give back? How can I create those opportunities for others? And very fortunately, again, through SAMPE, have had the opportunity to work with younger students. And in fact, in our conference that we've got coming up in April, we have some students in the local Seattle area that are going to be visiting the SAMPE conference, learning about composites and touring the floor. So I think part of it is just creating the awareness and providing the opportunities so that if folks want to jump, they can.
Yeah, thanks him, and thanks you for mentioning also the associations, I guess. The composite associations, lightweighting associations, technical associations have a big role in building the platform for this. I guess you would like to mention something, Alex, how you are handling this.
Yeah, on the end of the day, it's the same. You have to raise the interest of young people to go in touch with this. And on the end of the day, we have the challenge that mainly composite plastic is in the actual social interaction of the next generation, maybe not a fancy shit. Yeah, we have to change this. Composite has to be fancy. And in that case, you catch young people. So if it's for these guys, more or less old shit, destroying the planet, using oil or whatever, yeah, you will not raise the interest. No, composite is even more. And yeah, we have to address this, and this is a communication, this is marketing. Catch the young people, fancy shit, and the solution for the future, building light aircrafts, consumer products with high engineering skills, and yeah, interesting jobs. Why not?
I guess it is fancy. We have to talk the story or not. So, are there further questions? So we have time for one question. There's the next question.
Jan. So, for most of people, the future of the energy in the transport is the LH2. Do you trust in the compatibility with cryogenic liquid and composites, and therefore for the transport and the composites?
So you talked about liquid hydrogen storage systems?
Yeah, for the storage, yeah.
Maybe I can answer this from my perspective. I see the big opportunities there, but it's not only a technical question. It's also a question about building an ecosystem, building a market for this, and this is not so easy. So just take the example of sustainable aviation fuel. It is really, really hard to bring this into the market to get an acceptance for this. And of course, it's in minimum at the beginning much more expensive, but there should be an international will, especially in such an international environment and market section we have. So, and at the end, it's the same for hydrogen. When we don't bring it to an international market, to an international coordination, to an ecosystem, then it stays with the technical challenges, with the technical things. But I guess this we can handle at the end. Maybe it takes time, but the soft factors are much more important to take into account. So there's now the last question, but I can say when you have further questions, you can come to this area on the left-hand side, and everybody of us will be there to answer your questions, can get in touch with us. Yeah.
There were a couple dreams today announced. I have one more dream from a supplier that there is one source where we can qualify materials for the industry. Do you think this dream realistic? Tier 1 suppliers and airframers form some sort of consortium for material qualification? Or is it you want to preserve your competitive advantage doing it independently?
I mean, I think, yes, there's a competitive advantage component. I also think that there's just different philosophies and different approaches. So when you look at regulations, there's, multiple ways to fry an egg. There's different pathways that you can take to meet those requirements. And we all haven't taken the same exact pathway. So it's hard to fit totally into the same box. But that's where we can look to things like I mentioned before, the, NCAMP database that NIAR is working on, that, it's a start. It's a place where we can maybe get some of the data out there and have it more broadly applicable. But then I do still see, just because it would take such an effort to really change our philosophies, our design philosophies, our analysis philosophies, I'm not sure that that's very realistic. But maybe we could close the gap a little bit.
Thanks for the statement and thanks for this question. So now it's time for sum up a little bit, and I would like to take the advantage out of having a short, conclusive statement of each of you. Bertrand, please start with this, and we're going around.
Great discussion. I mean, we had a lot of dream together, so that was nice. No, I'm optimistic. I think it's a team thing. Yes, composite materials, they're not commodities. It's correct. But they displace metal because they are engineered materials. You can customize. So there's good and bad. But I'm optimistic that working together, we can from all along the supply chain, we can make it more robust, cheaper. That was one of the discussion we had. And meeting the rate. So I'm convinced there will be not less, but even more composite on the next aircraft. So looking to a 55 or 60% content.
Yeah, as mentioned, we have several views on that, the material supplier or the manufacturers. And on the end of the day, it's all about business. We have to find a way where we can achieve business benefits for all participants, all over the cost of ownership, from the raw material over the manufacturing, inspection, lifecycle management, MRO, ensure also the operator. And to be successful together is more or less a fundamental system for scaling up new technologies.
Okay. Well, I'd pinned all my hopes and dreams on the automated everything machine, but I don't think that's going to happen. So, but realistically, there's one thing that I will say for our industry, and it's our industries, it's all of us, right? Moving to a next generation single aisle that's a composite aircraft is a monumental shift in production, manufacturing, automation, material science. It'll take all of us, but it's really up to us. There's nobody's going to give us some magic recipe. We're not going to hand it to you guys, right? And you're going to hand it back to us. We have to determine our future, and it's up to us. It's everybody here. So we all have to figure it out. That's what I'm saying.
When we deliver machines, equipment, robots, automation to the aerospace industry, we have to take care to to take care of all the data from the raw material to the end of the part, that we have a full control about the data and the processes, so we can optimize this process and equipment by using innovative technologies. And I think this is the time to use it in production in a smart way.
Yeah, and kind of building off of what everyone has said before, I too am very optimistic. I'm excited about what the future holds. I definitely think there's opportunity to be collaborative while also still having, you know, our competitive advantage, if you will. There's certainly areas where we can collaborate. Things like we didn't talk a lot about today, but things like sustainability, I think, is very much an area where it's a team sport. We collaborate together and we can progress the industry forward.
So thanks for your statement. I guess a lot of optimism. We talked about challenges, but these are challenges. We are in a great environment. Some of the industries are facing with really problems. We are facing with challenges where a lot of solutions are. We have to collaborate. The future of aerospace, I guess, is with composites. This is key. The key is lightweighting technology. The key is, but also taking the people with us. And thanks a lot for all these statements, for this great discussion. It was really exciting. And it is a good point where we can bring also this passion to the younger guys. This is also really important. And thanks to the audience for the attendance, also for the good questions. Thanks to JEC, thanks to ST Engineering for sponsoring this. And see you next year, and maybe also at this show. Enjoy the day. Thank you so much.